Find the volume of the region under the surface z equals 2 divided by the quantity 1 plus x squared and above the triangle in the xy plane with the given corners. Notice how for these 3 points the z coordinates are 0, which means these 3 points are in the xy plane. If we plot these 3 points, it forms the triangle shown here on the right. Our goal is to find the volume under the surface given by z above this region in the xy plane. If f of x comma y is greater than or equal to 0 and integrable over the plane region R, then the volume can be found using this double integral where differential a is equal to dx dy or dy dx using rectangular coordinates. Before we set this up, let's look at this graphically. The graph of f of x comma y is the blue surface. This triangular region is the region of integration. Our goal is to find the volume under the blue surface and above this triangular region in the xy plane, which means our goal is to find the volume of this region here. Going back to our work, to determine the volume, let's actually set up 2 double integrals using different orders of integration, then determine which double integral will be easier to evaluate. And for our example, f of x comma y is 2 divided by the quantity 1 plus x squared. For the first double integral, let's let differential a equal dy dx, and then for the second double integral, let's let differential a equal dx dy. Going back over to the region of integration, we are going to need the equation of the line containing this side of the right triangle. Notice how this line has a y-intercept of 0 and a slope of 1, giving us the equation y equals x. For the first double integral, we integrate with respect to y first. So looking at the region of integration vertically, notice how we start at y equals 0 and then go up to the side of the triangle given by the equation y equals x, which means the limits of integration for y are from 0 to x because y equals x. Then we integrate with respect to x, which would be from 0 to 3. Looking at the second double integral, we integrate first with respect to x, looking at the region R from left to right. Notice how from the left we start at this side of the triangle given by the equation y equals x, and then we go out to x equals 3. So 3 is the upper limit of integration with respect to x. The lower limit is going to be, again, determined by this side of the right triangle given by the equation y equals x. We need to express x in terms of y, and therefore y is the lower limit of integration, again because x equals y. And then for the limits of integration for y, we integrate from 0 to 3. Now we need to decide which double integral is going to be easier to evaluate. Looking at the second double integral, if we integrate with respect to x first, the antiderivative will involve arctangent, and then we'll have to integrate that with respect to y, which gets fairly complicated. So let's use the first double integral to determine the volume, because looking at the integrand, if we first integrate with respect to y, we treat x as a constant. So integrating with respect to y first, again we treat x as a constant, and therefore the antiderivative is just 2 divided by the quantity 1 plus x squared times y. The limits of integration are from 0 to x. From here, remember, when determining big F of b minus big F of a, we're subbing the limits of integration for y, not x, which gives us the integral from 0 to 3 of 2 divided by the quantity 1 plus x squared times x minus 2 divided by the quantity 1 plus x squared times 0. This product is equal to 0, which gives us the integral from 0 to 3 of 2x divided by the quantity 1 plus x squared integrated with respect to x. Let's finish this on the next slide. Notice this integral requires u substitution, where u is equal to the denominator of 1 plus x squared, and therefore differential u is equal to 2x dx. And notice how this matches perfectly. The denominator is u, and 2x dx is equal to differential u. In terms of u, this is really just 1 over u du, which means the antiderivative is equal to natural log absolute value of u, which is really natural log absolute value of the quantity 1 plus x squared, which is always positive, so no absolute value required. And now we find big F of b minus big F of a, which gives us natural log of 1 plus 3 squared minus natural log of 1 plus 0 squared, which is equal to, here we have natural log 10 minus natural log 1, which is equal to 0. Natural log 10 is the exact volume, which is approximately 2.3026. And of course the units here would be cubic units because this is volume. Let's go back and look at our graph in 3 dimensions one last time. We just found that the volume below the blue surface above the triangular region in the xy plane is exactly natural log 10 cubic units, or approximately 2.3026 cubic units, which should be this volume here. I hope you found this helpful.